In this video, we'll solve a couple examples of linear equations in two variables by elimination/addition method. Basically, this method sometimes is called elimination, sometimes is called addition, depending on the problem, teacher's preference, and so on. So, let's try to solve this example. It says using substitution, but I want to use addition or elimination method. So let's take a look at the equation. I'm going to write it again. 5x minus 4y equals 1 and 4x plus y equals 5. So the idea of this elimination/addition method is to have in front of one of the variables, x or y, the same number, different signs. So for example, if I have x here and x on the second line, if I have 4 here, I should have 4 on the other one, and on one positive and one negative. So the first thing that I want to do is make sure my x and y's are aligned. So 5x and 4x are under each other, negative 4y, y, it's aligned, and the constants are aligned as well. So if they are not aligned like that, you'll have to move them around. So if we pick x, then in front of x, I want to have the same number. So that means I'm going to multiply the first equation by 4 and the second equation by 5, right? Because that will make it 20. Basically the LCD of the two numbers. So the LCD of 4 and 5 is 20. So how do I get 20 from 5? I multiply by 4. How do I get to 20 from 4? I multiply by 5. But I want different signs. So how about the second one would be times negative 5? I could have multiplied the first one by negative 4. So now, when we multiply 4 times each of the terms, we get 20x minus 16y equals 4. And negative 5 times 4x is negative 20x minus 5y equals negative 25. And now I'm going to add, that's where the name addition method comes from. So 20x minus 20x, that's 0. Negative 16y minus 5y is negative 21y. 4 minus 25 is negative 21. If we divide by negative 21 both sides, we get y equals 1. And now replace y equals 1 into any of the equations. So I'm going to replace into equation 1, in the first equation. So I get 5x minus 4 times 1 equals 1, or 5x minus 4 equals 1. Add 4 to both sides, so we get 5x equals 5, divide by 5, and we get x equals 1. So in other words, the solution, it's the pair 1, 1. Now, what if we had the same system of equation, 5x minus 4y equals 1, 4x plus y equals 5, but we picked y to eliminate. So before we picked x. Now, in front of y is negative 4, and in front of this y, it's actually plus 1, right? So what do we do, or what's the LCD of 4 and 1? Well, it's 4. So that means I will have to multiply the second equation by 4. So we are going to get 5x minus 4y equals 1, and 16x plus 4y equals 20. We notice that the signs are already opposite. So when we add, we get 21x equals 21. Divide by 21, and we get x equals 1. Now replace x equals 1 into any of the equations, let's say in equation 1. So we get 5 times 1 minus 4y equals 1. 5 minus 4y equals 1. Minus 4y equals negative 4. And y equals 1. So again, the solution is the pair 1, 1. So no matter what variable you choose, right, when we chose x, the solution was 1, 1. When we chose y, the solution was exactly the same, 1, 1. I can check by replacing 1, 1 in the system. So 5 times 1 is 5, minus 4 times 1 is 4, so we get 1, true. 4 times 1 is 4, plus 1 equals 5, that's true. So the solution 1, 1 is correct. So no matter what you pick, you get the same thing. That means choose the variable that gives you less trouble and less work, right? So in this case, I would have chosen y as my first choice because all I had to do is multiply the second equation by 4, while when we picked x, we had to multiply each of the equations by a number, and we also have to make sure we multiply by a negative. And let's solve one more problem using addition or this elimination method. So let's look at the system that we have. It contains fractions, so I'm gonna multiply by LCD to eliminate the fraction. The LCD of 2, 10, and 1 is 10, so I'm gonna multiply by 10, and the second equation I'm going to multiply by 6. So x plus 1 over 2 times 10, that's 5 times x plus 1, minus 10 divided by 10, that's 1, so minus y minus 2 equals negative 10. And the second one is x plus 1 plus 3 times y minus 2, right? Because 6 divided by 2, that's 3, equals 126. So we have two systems of equations with two unknown values. So what I'm going to do is I'm going to open the parentheses. So 5x plus 5 minus y plus 2, right? Because this is a negative 1 multiplied, changes the sign, equals negative 10. And then x plus 1 plus 3y minus 6 equals 126. So add like terms, we do have these two, and move them on the other side. So we get 5x minus y equals negative 17. And in this case, we have 1 minus 6. So x plus 3y equals 126 plus 5 is 131. Now when we take a look at our system, we have x aligned, y aligned, and then the constants aligned. I want to eliminate y because all I have to do is multiply the first equation by 3. So we get 15x minus 3y equals negative 51, and x plus 3y equals 131. So when we add these two equations, we get 16x equals 80. If we divide by 16, we get x equals 5. So now I'm going to replace x equals 5 into one of the simplified equations. So I'm going to replace it in here to find y. So we get 5 plus 3y equals 131, 3y equals 126, divide by 3, and we get y equals 42. So in other words, the pair 5, 42, it's a solution of the system. Now, I can check the pair 5, 42 to see if it's a solution by replacing in the original system. So I'm going to replace in these two. In the original ones, not in the intermediate ones, because if you replace in the intermediate ones and you made a mistake somewhere, it's going to satisfy the equation, but you are working with the wrong one. So anyway, let's replace, instead of x, we put 5. So 5, I'm going to the first equation. 5 plus 1 is 6 divided by 2 is 3, minus y minus 2. So 42 minus 2, that's 40, divided by 10, that's 4. And 3 minus 4 is exactly negative 1, so it checks out. Now I'm going to replace in the second equation. So 5 plus 1 is 6, divided by 6 it's 1, plus 42 minus 2 is 40, divided by 2 it's 20, that equals 21. So yes, the pair 5, 42 satisfies the system.